Welcome, my students. Welcome to my class. Today, I have brought here the question from grade 9, okay? Which I have displayed, okay, in this video. According to this question, look here. The question is given like this. Look here, I want to show you here. It is displayed also. Question is there to prove. Right, I want to show you here also. Prove. The question is 2 cos square alpha, right here. 2 cos square alpha, okay, 2 cos square alpha minus 1. Here is minus 1, right? Here is minus 1, and this is divided by sine alpha cos alpha, right here. Sine alpha into cos alpha, okay? And we have to prove that its result is given there to prove cot alpha. There is given here cot alpha minus, and we have to bring there tan alpha. This is the answer we need to bring by solving its left hand side, okay? And look here, students. First of all, we are solving left hand side here, okay? We are simplifying left hand side and we are trying to get this right hand side one, okay? Here, according to this question, what is given? Write this first here. 2 cos square, right? And alpha minus 1 and its whole upon is given there sine alpha into cos alpha, okay? Here is given here sine alpha into cos alpha. It is given there, okay? Now look here, students. The first step that we need to do here is this is given. Look here, this is 2 cos square alpha given, that we have to break down, okay, in two parts, that is cos square alpha. This technique you have to understand while solving this question, okay? Here's minus 1 and I have written that another cos alpha here, okay? Okay, cos square alpha, because we know that this cos square alpha, okay, this cos square alpha and this cos square alpha, if we add, it will give 2 cos square alpha, okay? This term will be given by this adding this cos square alpha and cos square alpha. That's why this is broken into two parts, that is we have divided into part, that is cos square alpha, okay? Why do you know why we have separated them in two parts here because there is no formula of this 2 cos square alpha minus 1 in grade 9, okay, of trigonometry 1, right? That's why we have separated them in two parts, cos square alpha, cos square alpha, okay. This is sine alpha, okay, into here is cos alpha, okay, right here like this. Clear? Now, when we take the common, this one, look here, this common from this two terms, minus 1 and cos alpha, in this plus also there are two minus, okay. That's why write like this, look here, cos square alpha, right, minus, if we take common minus here, and in bracket there remaining 1 and minus, because in this plus there are two minus, we have taken 1 minus common, okay. Then what is remaining here? Inside the bracket there is remaining cos, okay, square alpha, right, right like this, and its whole upon there is given sine alpha, okay, into cos alpha, okay. Now if you remove this bracket, here is, look here, see here, cos square, okay, alpha minus 1, right, then we know that, look here, this 1 minus cos square alpha means this value, you know, it is in the formula of Pythagoras relation, okay. As we know that, I want to show you here, sine square alpha, okay, plus cos square alpha, okay, that you have learned in Pythagoras relation, right? It means it was 1 right there, okay, it was 1. Then when you take this cos alpha on the right side, okay, then there will be minus, no, that's why in this place, look what will come there, 1 minus cos alpha means we can write there like this, okay, sine square alpha, this bracket 1 is in sine square alpha, right, and write its whole upon there is given, there is sine square, right, this is sine square alpha into this is multiply, okay, dot this dot cos square alpha, this right same, okay, there is single term in the denominator, right, and when there is single term and upper one, numerator is two terms, now look here children, we can separate like this here, right, like this cos square alpha, right, okay, and down what is there, single term this right here, okay, it will remain here, okay, sine square alpha, okay, write the same sine square alpha into cos square alpha, right, this copy the same sine square alpha and cos square alpha, right, and here is minus, then write this separately, okay, sine square alpha, okay, by here is again the same denominator, this one right here, sine square, okay, alpha into what is there, okay, look children, here is no square, okay, this is copied one, this one, okay, there is no square here, okay, I want to show you there, here is no square, it was copied little bit, look there, look here is only sine alpha, okay, here was square but there is no square in denominator here, Here write sine alpha into, here is cos alpha only. There is no square in denominator, right? Write the same. Sine alpha cos alpha only, okay? And upper one there is square, right? Now let's follow the same step here also. We do the same step here. What will happen? Look here, students. Here is cos square alpha for that same method by, what is this here? This right separate, okay? This term is divided by this denominator, that is sine alpha, okay, into cos alpha. There is no square, okay? In denominator there is no square. It was copied square mistakenly there. And here is minus. Now what is there? Sine square, right? Down there is, like this, look here, sine alpha into, right here, cos alpha. Okay. Now look here, so now we up and down, we can look at this cos alpha, and this here is down. There is one cos alpha. Okay, this is one cos alpha cot, and here is one sine square. There is the sine square. That's why one sine alpha is cancelled with this one sine alpha. Then what is remaining here? Look, here is remaining cos by sine. Okay, right here, remaining one is here, cos alpha by sine alpha. Okay, right here, cos alpha by sine alpha here. Okay, and down there is now minus, what is this? Here is remaining sine alpha by cos alpha right here. Remaining one right there, sine alpha, okay, by, here is cos alpha right here. Sine alpha by cos alpha. Okay. Then we need to write here cos by sine means we have to write here now cot alpha. Okay. Cos by sine means cot alpha minus sine by cos means we have to write here tan alpha. Okay. That was the result we need to bring on the right side. This is our, okay, result to bring, and it was given in right hand side right here. We brought right hand side and our solution. Okay, the question is proved now. Right here, proved. Okay, like this we have to solve this type of question. I hope you are clear about this. Now I want to say here, next question. If the question is given in this form, look here. Look, I want to clear this one, okay? I hope you understood this and you can solve this easily. Now, welcome students. Welcome to my Okay, now next question that I want to say here. This sound clear? Okay. The next question is this one. Look here. When you solve like these questions, how to, okay, how to do? The question is, this one. Look here. If there is given 1 minus, right, there is given tan alpha, 1 minus tan alpha, right, and by 1 plus tan alpha. Okay, there is the question like this: 1 plus tan alpha, 1 plus tan alpha, and its result we need to bring. The answer is given there: cot alpha. Here is given cot alpha, right, minus 1, and divided by there is cot alpha, okay, cot alpha plus 1, right, like this one. In this condition, how to do? Look here. Look here. For this one, there is, first of all, write the LHS, okay, and write this 1 minus tan alpha, write it, okay, tan alpha, and there is next one is 1 plus tan alpha right here, and we need to look the result that we need to bring on the right hand side. Here is tan, but we need to bring answer in cot here. There is okay, down also cot, and there is only one relation that we can bring from tan into cot is that we know tan alpha means what do you know? We have the formula tan alpha equals to 1 by cot alpha. This relation we have to use here. Okay, this one we have to use in this formula because from this tan we need to bring cot, that is only one. Okay, there is tan alpha equals to 1 by cot because tan and cot are reciprocal to each other. Right here 1 minus, write this, okay, in place of tan alpha we have to write, now we need to write a 1 by, okay, cot alpha because we need to bring the cot on the right side. Look here, that's why tan convert into cot, and its whole upon there is okay 1 plus, here also we can open this tan alpha means 1 by cot alpha open here like this, open this, okay. Then now if we take LCM here of this is cot alpha, right here cot alpha, okay, then cot alpha will, here is down 1, nothing means here 1, no? That's why then this cot alpha will multiply with 1 and this 1 multiply with this 1, okay, and here remain 1 into cot alpha means here will be cot alpha minus 1, and down 1 is there, this cot alpha will multiply with this one here, okay, and this one will multiply with this one here because we know its LCM also. What is there? Cot alpha, right? Right here cot alpha, then now cot alpha into 1 means right here cot alpha right here, okay, then this side there is plus 1, okay, this is 1. Now we can cancel this cot alpha, this cot alpha, and result is there, right, this one, okay, answer came, right, that is given on the right side to bring cot alpha minus 1 whole upon there is given cot alpha, okay, plus 1. That, okay, this is the condition that we need to bring, which was given in the right hand side. Okay, then we have provided is proved. Our question is proved. Okay, right here it is proved. Right, we have to like this. I hope you understood it. If you have any difficult question in trigonometry, okay, of your class, okay, you can share your difficulties in comment box so that I can help you for your, okay, easiness. Right? Okay, today this much only, and I will come in next video in live, okay, by taking other problems of your class. Okay, so today this much only. Bye bye. See you in next video.